So, hello students, let's discuss about the last topic of the chapter, which is actually bonding in metal carbonyls. Metal carbonyls, especially the bonding of metal carbonyls, why given in the book, in our syllabus, we have to be discussed why the especially metal carbonyls compounds are going to be studied here. The reason is metal carbonyl compounds are actually generally comparatively more stable than the other ligands complex formation. So today we have to be discuss why metal carbonyl compounds are generally more stable comparatively all those ligands like ammonia, cyanide, halides and the other ligands. Carbonyl compounds means a carbon monoxide. Carbonyl compounds means carbon monoxide. It is known as carbonyls in a complex formation. So first let's discuss which type of compounds are complex generally formed by the metal or metal cations with carbon monoxide. Generally, the neutral metal coordinate with carbon monoxide to form a metal carbonyl compounds. Means generally the metals carry zero oxidation state during the combination of carbon monoxide called carbonyl complexes. Because itself it is a neutral molecule which can be easily donate a lone pair to the metal empty orbitals. Many of the times students are actually confused which of the atom of carbon monoxide, either carbon or oxygen, will participate in the bonding. I don't know what you can guess about this. Even oxygen having a lone pair of electron, but in the carbonyl complex formation, the carbon atom donate its a pair of electron to the metal, and you should surprise to learn it. Instead of oxygen having a great tendency, instead of oxygen having a two lone pairs, this carbon atom that will participate in the coordinate bond formation because of the presence of a pair of electron along with it. It is an exceptionally modified molecule of the carbon and oxygen where carbon having a pair of electron with itself that easily can be participate in the bond formation during coordination with the complex. The same time, the pair of electron of carbon which is actually present in the bonding possibility, the anti-bonding orbital of the same carbon is empty that may also participate in the bond formation. That is the additional feature here in the carbon monoxide compound. So students, you learn it. You should learn it. What is the proper condition of the making of the coordinate bond formation of the carbon monoxide with the complex, with the metal. So before it, let's first discuss some of the structures and compound given in the NCERT, like tetrahedral complex formation of nickel and carbon monoxide. The compound is this is the complex carbon monoxide. You can guess here nickel having a zero oxidation state. Nickel carry a zero oxidation state, and that's why the electronic configuration remain 3d8 4s2. Carbon monoxide is the most strong ligand as spectrochemical series tells about. So the electron must be get paired, and in side state there will be T2Z 8 and T2G 6 and EC4, and that is the reason the hybridization takes place is sp3 and complex formation is tetrahedral. So the complex of nickel here will be the complex formation of nickel with the 4 carbon monoxide is a tetrahedral condition. Look at the electronic configuration in the crystal field theory. In the excited state during bond formation, which is T2G6 and EG4, there are 10 electrons. Means this pair of electrons from the S will enter in the inner orbital. That will complete the pairing of the d orbitals, and only outer S and outer 3 orbital of the P participating in the bond formation, giving you sp3 condition. This is the condition. The next complex is FeCO5. I explained in the very previous lectures, the coordination number 4 can give you two different types of hybridization and two different types of geometry. If sp3 tetrahedral takes place, if dsp2 square planet takes place. But in the case of coordination number 5, there is only one possibility, and that is sp3d. sp3d, that will give you a trigonal bipyramidal possibility of the complex. So here also the FeCO5, this complex is trigonal bipyramidal. So trigonal bipyramidal structure of this complex, you can write the name also. The pentacarbonyl iron, oxidation state 0. The tetracarbonyl nickel, the name of the complex. The next example of this in the same series, that is chromium. The complex formation of chromium with the carbon monoxide with the coordination number 6. Coordination number 6. So the complex is like this. Chromium, the hexacarbonyl chromium, the name of the complex. And as you know that no matter what is the hybridization in the case of coordination number 6, the geometry always will be octahedral. So this geometry also will be octahedral, and you are knowing the structure of octahedral possibility. So all these 6 hadron will occupied by carbon monoxide that will coordinate a pair of electron to the chromium. To the chromium. What is the electronic configuration of chromium you are knowing about? What is the configuration? The configuration is D5S1 in the ground state, but carbon monoxide, as you know, it is a strong field ligand that will get paired these electrons in the T2G set. And now you can see that the T2G will receive all 6 electrons, and EG, the 2 orbital of the inner orbital, the 2 orbital from the inner D subshell will available for the hybridization. So the hybridization of this complex will be D2sp3 condition. A D2sp3, because 2 orbital from the inner D subshell is available here. As you can see, the EG is 0. According to crystal field theory, the complex formation will be D2sp3. There are some other examples also given, like Mn2CO10. Mn2CO10, it is actually a bicentered metal in a trigonal pi pyramidal condition. Bicentered means the Mn bonded with itself to form this like molecule, and 5 carbon monoxide will occupy in the 5 trigonal bipyramidal possibilities. 5 carbonyl with the 1 Mn and 5 carbonyl with the other Mn. There will be a trigonal bipyramidal structure individually for 1 manganese. Bicenter metal condition. And next possibility of the same, CO2CO8. One more complex given there. This complex, this complex, this is the exceptionally complex having a bridging of carbon monoxide. Bridging. Students, how can be carbon monoxide will form the two different coordination possibility? It can be explained on the basis of this complex only. As earlier in the lecture, when I started, I asked to learn you that carbon monoxide having an anti-bonding orbital which is empty and bonding orbital which having a pair of electron that coordinate towards the metal. That's why this condition, the carbon monoxide here, that will combine with this is a cobalt, and this carbon monoxide will coordinate with both the cobalt together simultaneously. The same structure given, you can see in the book also. The two bridging carbon monoxide indicating the possibility of the two different coordination possibility of the same carbon monoxide. Look at the possibility. There will be a single bond of cobalt metal. This is called metallic bond between the cobalt, and these two are the called coordinate bond based on the bonding orbital and anti-bonding orbital participation of the carbon monoxide individually with both the cobalt. And other 6 carbon monoxide will be 3 here and 3 here. This is called a 3-terminal carbon monoxide per cobalt and 2 bridging carbon monoxide per cobalt. So total number of carbon monoxide means carbonyl compound is 8. These some structures given in your NCERT. But we have to be discussed how this kind of possibility can be takes place. Why carbonyl complex formation with the metals are generally very high stability, are more stable comparatively with the other complex. Let's discuss about that, the bonding possibility in the metal with carbonyl compound. Students, first learn it, the metal having at step empty orbital from d subshell to receive a pair of electrons from the carbon monoxide. Carbon monoxide must be having a lone pair of electron that can be coordinate with the metal. There should be some distance now to indicate it. So this is a pair of electron, a filled electron, and this one is the empty orbital of the d subshell from the metal that will be involved in coordinate bond formation. Okay, this is a regular bond of coordination between carbon and metal. The same time, some of the orbital some of the more orbital of the d subshell that can be filled in the metal, these are called a filled orbital of the metal, and same time this is a anti-bonding p orbital of carbon. Hello, this is an anti-bonding p orbital, and these are the filled, this is called a p orbital and d orbital, sorry, d orbital of the metal that having a filled electrons. So availability of filled electron in the d subshell of the metal can coordinate, can make a pi bond. Make a pi bond. This is a sigma one. Coordinate bond is always sigma bond. But here a pi bond takes place. A pi bond takes place. And this type of bonding is called this type of bonding called synergic bond. A new name of the bond formation. Students, you should learn that the synergic bond is actually called an additional bonding along with the coordinate bond between a filled d orbitals of metals and anti-bonding pi orbitals of the carbon. Anti-bonding pi star. These are called a pi star actually. Anti-bonding. So here the anti-bonding orbitals are empty in the case of carbon because a pair of electrons present in the bonding condition that coordinate with the metal. So the sigma bond formation between a bonding orbital of carbon with metal, empty orbital of metal, and pi orbital takes place between a filled orbital of metal with anti-bonding of the pi orbital of the carbon. These are called additional pi bond. And you should learn that whenever there is a double bond character between any compound, between two atoms, the double bond is always having a more possibility of stability than a single bond. The double bond having more bond dissociation enthalpy. This is the one of the reason why carbonyl complexes are really more stable, and most of the metals take part in the formation of complex with the carbon monoxide because of this additional pi bond, which will increase the stability of the coordinate complexes. Increase the stability of the coordinate complexes. So we can see that this type of additional feature of pi bond formation called synergic bond. This only takes place in the metal carbonyl complexes. And that will explain the stability, the additional stability of the complex. Okay, this is all about the metal carbonyl complexes. Now here some importance of and applications of coordination compounds also given. You can go through that. Many of the applications and coordination importance given. You can go through the NCERT book for the reading. And next thing is about some questions. So for questions there will be a next video that will be uploading within 1 or 2 days. You can go through the different questions through that video. This is all about the coordination compounds. We can sum up or rewind the things what we learned in the previous lectures, students, because we have enough time to rewind that. We started from the introduction of the coordinate compounds, as you know. Then go through the oneness theory that will actually discuss about the primary and secondary valency, the ionization and the ionizable valency, non-ionizable valency. How can we calculate the coordination number? Coordination number means how many number of coordinate bonds formed between the ligands and the central metal atom. Ionizable means the counter ion that actually balance the complex. If the complex is cationic or anionic, some of the cations are anion, balance the complex which is ionizable in nature called ionizable valency. You are knowing about. Then we gone through that IUPAC nomenclature. And for that IUPAC nomenclature we have to go through that the name of the ligands, anionic ligand, generally end with IDO, sometimes only O. As you know, chlorido, bromido, iodido, cyanido or cyano, thiocyanato, nitrito. Valency bond theory and crystal field theory. The main two different theories given to explain the nature, behavior and properties of the coordination complexes. Why this kind of bond formation takes place. How the magnetic behavior can be explained. Why there is a splitting of the d orbitals and how the electrons are filled in the different d subcells. like three different set of the orbital called T2, the two different orbital set called E, splitting. These some things are we explained in the previous lecture. You can go through all these topics to detail about the concept of the same coordination compounds. Okay, and we will discuss about some more things in the next lecture that will be based on the questions, because some of the concept can be explained on the basis of questions given in the book, and that will be very helpful for the board examination as well as the competitions. How we treat the magnetic properties, how can we solve the magnetic properties question, valence bond theory questions and crystal field theory questions. Okay, so concluding the lecture here only, we'll discuss about other doubts in the next session.